Hello friends, welcome in a lecture of Mechanics of Solid subject. Myself Mitesh Patel. I am a assistant professor in a mechanical department at a Dr. Subhas Technical Campus, Junagadh. Today's our lecture topic is a introduction of mechanics of solid. So in this lecture we discuss about what is the mechanics and what is the mechanics of solid and some terms and laws which are included in this subject and really helpful in this subject. Okay, so let's start the lecture. Okay, so first of all we see the what is the mechanics. Okay, so mechanics is the one kind of science which related with the forces apply onto the body when body in rest condition or in motion condition. Okay, so mechanics is the one kind of science in which the study the when the force are applied onto the body, and that kind of studies in this mechanics science. Okay, so now what is the applied mechanics? The applied mechanics is the approach is to study systematically the laws of mechanics and their application to the engineering problems. Means applied mechanics is the application of the mechanics to the real problem. In short, we can say that the applications of all the knowledge of mechanics to the real problem, that's called the applied mechanics. So as an engineer, we can study the or we have to study the applied mechanics. So we see the classification of the mechanics. First of all, we see the mechanics, and as an engineer we know that we have to study the applied mechanics. We study the applied mechanics, and further types of applied mechanics is the mechanics of rigid body and mechanics of deformable bodies and mechanics of fluids. So applied mechanics it's divided into the three category: mechanics of rigid body, deformable body, and mechanics of fluids. Mechanics of rigid body means the body is rigid, not any kind of change according to force applied onto it. And when mechanics of deformable body, the body is deformed due to the force. That kind of applications or studies it consider into the mechanics of deformable bodies. And the mechanics of fluids, in this sense we can study we study in this sense the behavior of fluids, properties of fluids, and how its flow and number of forces according to fluid flow. Okay, so in particular in this subject we study the static and the mechanics of deformable body, means the strength of science. So mechanics of rigid body is also called the engineering of mechanics. So mechanics of rigid body is also divided into two categories: static and dynamics. Static, as per the name, we know that when the body is in rest condition, and then time the force are applied onto that, and studies on that type of cases considered in the static. And in dynamics, when body is in motion. So when body in motion and force studies are considered on the body, when the body in motion, that all things are included into the dynamics. Okay, so dynamics are also further divided into the two category: kinetics and kinematics. Okay, so kinetics and kinematics is two types of branch of dynamics, in which the kinetics, the study of motion of the body, is study, and also the responsible forces are also considered, but in kinematics only consider the motion of body and study the motion of body, not consider the causes of motion, means the force, which kind of force are applied onto the body, which type of that, it's not considered in kinematics, only consider the motion of body. But in kinetics both are considered, the force, which kind of force are apply onto the body, that's also considered with the motion of body. Okay. So in this subject we study the static and strength of material, means the mechanics of deformable bodies. Now see the some fundamental terms which are helpful in this subject. Okay, so first is a space. So how to define the space? We define as a space is a region in which all things are included or contain this region. This called the space. Okay. So second is the time. So time is the measurement of duration between the two successive events. The time is measure the events or duration of events. So it's called the unit of durations or successive events. Okay. So SI unit of time we all know that the second. Okay. Then next is a matter. Matter is the nothing but substance that possess the weight and occupy the space that can be called as a matter. Okay. Matter is nothing but the something entity which having a weight and occupy the space and can sense is called the matter. Okay. Then next is the body. Body is the matter bounded by the closed surface is called the body. Okay. Just like a bus and earth, the bus having a body or casing over that is called the body. Okay. So body is nothing but the casing of the all parts or matter. Okay. Now what is the inertia? Inertia is a property of any matter or any material. In this particular property, by which the body offer resistance to any change of its state or motion condition. Means when body is in motion, then we have to stop that. Then body is opposed to stop. It's continuously its position or it's continuously its state. Okay. So a body is opposed to change the state. When body is in rest and we have to start the motion or give to the motion, then the body is opposed to create the or generate the motion. Then that type of property of body is called the inertia. Okay. જ્યારે બોડી મોશનમાં હશે ત્યારે એને આપણે રોકવા જઈશું ત્યારે બોડી ઓપોઝ કરશે મોશનને રોકવા માટેનો. બરોબર છે? તો એને શું કહેવાશે? એ પ્રોપર્ટીને ઇનર્શિયા કહેવાશે. બરોબર. Then next is a mass. The quantity of matter contained by the body is called the mass of body. It is the quantity measurement of inertia. Okay. So mass is the nothing but the how much quantity of matter contained in the body is called the mass. If the matter are tightly or much are contained in a body, then mass is higher. If the content is lower in body, then mass is less. Then we take example of sponge and stone. Stone having a mass, higher mass, and sponge having a very less mass, because the content in the sponge are very less, because it is porous, is having a porosity. So matter contained by the sponge is very less compared to stone. So mass of the sponge is less. Okay. Now the rest and motion, we all know that when the body is said to be rest, when does not change its position with respect to time. If the body is changed with respect to time, its position is called the motion. Okay. Now see the other terms. Particle So idealized terms which are assumed by the science or assumed by us, that types of terms we see that now. So first of all, it's a particle, it's an ideal or assumed body which not having or having a negligible mass, or which having a size and size shape can be neglected. So it's having a very small type of entity, it's not having a mass, shape and size. It's considered or assumed type, one kind of particle, it's a assumed entity. Okay. Now next is the rigid body. The rigid body rigid body is a body said to be rigid if relative distance between the particle of the body remains same before and after application of force. When we apply the force onto the body, but not change any shape and size of the body, then body is called the rigid body. Okay. And similarly, what is the deformable body? Deformable body is deformed under the action of force. Its shape and size is changed under the action of force. Okay. It's called the deformable body. Okay. Now the another assumable word is a continuum. It is defined as the idealized body whose matter is assumed to be totally continuous, homogeneous, non-porous. Okay. So continuum is a idealized word. It's assumed that the condition that material is the homogeneous, totally homogeneous, nothing any kind of impurities in the material, and it's not porous, not any kind of porosities, and it's continuous. So it's called the continuum. Okay. So these all are the idealized words which are used in the subject. Okay. Now the basic fundamental principles, some of are also are aware about this principle, but we recall that. Okay, you all are aware about that, but we remember again, or we discuss about again. Okay, so first of all, first is a law of parallelogram or parallelogram law of forces. Second law is the principle of transmissibility. Third one is the principle of superposition of forces, and the remaining is the Newton's law of motions. Okay, and last one is the Newton gravitational law. Okay, so all are described or elaborate. Okay. So parallelogram law of forces. In this law, for to find out the resultant of two forces which are simultaneously apply onto the same particles. Okay. So if two forces acting simultaneously on a same particle and represented in magnitude and direction by two adjacent side of parallelogram, their resultant may be represented in magnitude and direction by diagonal of parallelogram. Okay. The law is define the resultant when the two forces are applied onto the particle simultaneously. Okay. So let's take an example. If two forces are applied onto the same point, then these two forces are considered as a two adjacent side of parallelogram, means the સમાંતર બાજુ ચતુષ્કોણ એની બે પાસે પાસેની બાજુ તરીકે કન્સિડર કરી લે. then the diagonal of parallelogram is provide the resultant magnitude and direction. બે ફોર્સની જે રિઝલ્ટન્ટ મળે છે એ રિઝલ્ટન્ટ આપણને એનું વિકિરણ એ રિઝલ્ટન્ટ પ્રોવાઈડ કરશે. બરાબર છે. જો બે ફોર્સ સાયમલ્ટેનિયસલી કોઈ પણ એક પોઈન્ટ ઉપર જ એપ્લાય થતા હોય તો એને જો પેરેલોગ્રામની બે બાજુ તરીકે દર્શાવીએ, સમાંતર બાજુ ચતુષ્કોણની બે બાજુ તરીકે દર્શાવીએ તો જે ડાયાગોનલ છે વિકર્ણ છે ચતુષ્કોણનું એ આપણને રિઝલ્ટન્ટ આપશે. બરાબર છે. એ પેરેલોગ્રામ લો ડિફાઇન કરે છે. આ લોને શું કહેશું આપણે? પેરેલોગ્રામ લો. બરાબર છે. એના પછી છે પ્રિન્સિપલ ઓફ ટ્રાન્સમિસિબિલિટી. આ લો શું કહે છે? તો કે ઇફ ધ ફોર્સ એક્ટ any point on rigid body, it may also be considered to act at any point, any other point on its line of action. Okay. Let's understand with the example. If this is a body, if one force is applied onto the body on this point, then this force is also considered as a this point of body instead of this force to this force. Okay, at a line of action of force. Okay, એનો અર્થ એવો થયો કે જ્યારે કોઈ પણ એક ફોર્સ કોઈ એક બોડી ઉપર એપ્લાય થાય છે, બરોબર, કોઈ પણ એક પોઈન્ટ ઉપર, તો એ ફોર્સને આપણે એ જગ્યાએથી બીજી જગ્યાએ આપણે કન્સિડર કરી શકીએ છીએ બોડી ઉપર, પણ એઝ્યુમ પોઈન્ટ છે એ લાઇન ઓફ એક્શન ઉપર હોવું જોઈએ. એટલે કે આ ફોર્સને આપણે અહીંયાથી પણ બતાવી શકીએ. બરોબર છે. તો એ પ્રિન્સિપલને શું કહેવાશે? પ્રિન્સિપલ ઓફ ટ્રાન્સમિસિબિલિટી. ઓકે. એના પછીનું છે પ્રિન્સિપલ. નેક્સ્ટ પ્રિન્સિપલ ઇઝ ધ પ્રિન્સિપલ ઓફ સુપરપોઝિશન ઓફ ફોર્સીસ. If the two equal opposite collinear forces are added or removed from the system of force, there will be no change in the position of body. Okay. This principle is defined that. Let's understand with the help of example. This is the body. When two equal and opposite forces are applied onto the body or remove from the body or remove from the force system, that nothing change in the position of body. It's called the principle of superposition. એટલે કે જ્યારે બે એક સરખા ફોર્સિસ 10 ન્યૂટનના બે ફોર્સિસ એપ્લાય થાય છે બોડી ઉપર, બરોબર છે, કોલિનિયર, ઇક્વલ એન્ડ ઓપોઝિટ. બરોબર છે. ત્રણેય શરત હોવી જોઈએ, ત્રણેય કન્ડિશન ફૂલફિલ થવી જોઈએ. મીન્સ કે કોલિનિયર ફોર્સિસ, ઓપોઝિટ ફોર્સિસ બે એકબીજાને ઓપોઝિટ હોવા જોઈએ અને ઇક્વલ હોવા જોઈએ. બરોબર છે. અને કોલિનિયર હોવા જોઈએ. બરોબર છે. તો એવા કેસની અંદર બંને ફોર્સ એડ કરો, આવા ફોર્સ, અથવા તો બે ફોર્સ આવા સિસ્ટમમાંથી રિમૂવ કરી નાખો તો બોડીની પોઝિશનમાં કંઈ પણ ફેરફાર થશે નહીં. This law is called the principle of superposition of forces. Okay. Now next is the Newton first law of motion. Okay. So we all aware about the Newton first law of motion. What is the motion? Every body continues in state or rest or uniform motion unless it's compelled change the state by external force. In short, we can say that the body is continuous in state when body is in motion is continue its motion, or body is in rest, it's continuously in rest without any kind of external force given to the body. If the force is given to the body, then body is start to move from the rest condition, or if body is continuous in motion, if we applying the external forces, then body will be stopped from the motion condition. Without any external force, nothing change in the motion or rest condition of every body. Okay, this is the first law of Newton law for a motion. Okay, now Newton second law for motion. Okay, it's defined by the acceleration of body is proportional to the impressed force take place in the direction of the force act, or we also can say that the rate of change of momentum is directly proportional to the applied force onto the body, or we can say that the force is directly proportional to acceleration applied to the body. Okay, and F is equal to A, directly proportional to A, and proportional, if we equal to the force and acceleration, the constant is added, and this constant is called the m, and is representing the mass of body. So F is equal to mass into acceleration. This is the second law of motion for of a Newton. Barabar? Next is the Newton third law of motion. So third law of motion of a Newton is every action have a equal reaction. Okay, action and reaction are there. We know that for every action there is always equal reaction are there. This is the Newton's third law of motion. And best example આપેલું છે. Best example is the rocket. The rocket are moved due to the reaction of jet propulsion forces. Okay, the force is applied into the force is generated due to the jet side, and due to the jet forces, the opposite forces are generated into the rocket, and rocket is move up. Okay, so every action having a equal and opposite reaction. This is the Newton's third law of motion. Okay, now next is a Newton's law of gravitation. When two bodies are attracted toward each other along the line containing them with force which is directly proportional to the product of their mass and inversely proportional to the square of the distance between them. Okay, in short we can say that every body are attracted to each other. Sorry. Every body are attracted to each other, and this attraction force is directly proportional to the product of masses of both body and inversely proportional to the distance between them, distance square of the distance between them. Okay, as mentioned is here, the force is directly proportional to the both mass of the body and inversely proportional to the square of distance between them. Okay, these two bodies are attracted to each other, and this attraction force are equal or proportional to the mass of these two body or product of these two body of mass, and the force is inversely proportional to the square distance of these two body. Okay, and when equal the by applying the constant G. Okay, so G is the constant, or it's called the gravitational constant. Okay, or capital G is the universal gravitational constant, and here we consider F is equal to mg, or according to that for a earth condition. And if we consider the earth, and on earth, if this is the surface of earth, and on this surface the mass is there, And then according to gravitational force, or according to law of motion, law of gravitation of Newton, so attraction force is directly proportional to mass of this body, small m, mass of the earth, capital M, and inversely proportional to distance between them, the radius or distance between these two body, okay, and square of the distance between two body, okay. So here these are mentioned, and the capital G is the universal gravitational constant, and the all things capital G, capital M and R square are the common for the earth. Capital G is the universal constant, the constant is not change. Capital M, mass of the earth, is not change. R is the radius of earth, it's not change for earth. So G, M and R is not change for the earth, so it's combinedly considered as a one constant, small g. It's called the again gravitational constant for the earth, okay. Small g is the gravitational constant for earth, and its value is a 9.81 mass per second square. If we go to the moon, then the value of g is changed, because small g is the for the earth, okay. Now next is the fundamental units. We all know about the units. The main fundamental units is the length, mass and time, okay. So length fundamental unit is the mass, meter. Mass fundamental is the kg, and time fundamental unit is a second, okay. So all other units are derived units from this fundamental, these three units, okay. So we all know that all things are there. Now system of units, we know that the mainly system of unit is the CGS, MCAS, SI unit, Indian Standard Unit and FPS unit, okay, or FPS system, MCAS system, CGS system, FPS system and SI system, International Standard System, okay. So FPS means the foot, pounds and second, CGS means centimeter, gram and second, MKS means meter, kilogram and second, and international standard, according to international standard, meter, kilogram and second, okay. So all fundamental units according to this system are given, okay. We all know that about that, and the international standard units for the physical quantities, the length unit is a meter, mass unit is a kilogram, time for second, temperature unit Kelvin, electric current unit is a ampere, luminous intensity unit is a candela, and amount of substance measured unit is a mole, okay. And the plane angle, we all know that, measured by radian according to SI system. The SI system, the plane angle unit is a radian, and solid angle means the three-dimensional angle measured with the steradian, okay. Now another physical quantities which are derived units from the basic fundamental units, okay. So force unit is a Newton, okay. Force unit is a Newton, and Newton made from the kg into meter per second square, okay. and the work unit is a joule. Okay, Newton into meter. The work is defined by the distance moved by the body according to force applied in this direction. So force into distance, Newton into meter. Okay, the power unit is a what? Joule per second. Okay, energy unit is also joule. Area unit is a square meter square. Volume unit is a meter cube. Pressure unit is a Pascal or any other Newton per meter square. Velocity or speed unit is a meter per second. Acceleration unit is a meter per second square. Angular velocity radian per second. Angular acceleration radian per second square. And the momentum meter per second, kg into meter per second. And the torque unit is a Newton into meter. Density kg per meter cube. Couple unit is a Newton into meter, and moment unit is a Newton into meter. Force into distance, force into distance. Okay. Now the prefix are according to prefix add to the units, and its some values are there. Okay, so this is very important, and we also all are aware about that, but we again recall that we know that in plus side deca means 10 raised to 1 means the 10 is called the deca. Hecto means the 10 raised to square. Kilo means 10 raised to 3. Mega means 10 raised to 6. Giga means 10 raised to 9. Tera means 10 raised to 12. Okay. So, we can say that the kilogram means the gram into 10 raised to 3. Then it's called the kilogram. Okay. Hecto means 10 raised to 12, and the deci is a 10 raised to negative 1. Deci means 10 raised to negative 1. Centi means 10 raised to negative minus 2 or 10 raised to minus 2. Milli means 10 raised to minus 3. Micro means 10 raised to minus 6. Nano means 10 raised to minus 9. And pico means 10 raised to minus 12. Okay. So from deca to tera is the bigger unit, and deci to nano is a smaller unit. Okay. Now conversions of unit are very important or very useful in this subject, because the data or your examples data are given in the some other unit than the SI unit, but we have to solve the example in a SI unit. So we have to convert the given unit into SI unit. So we all know the conversions of unit is very important for this subject or any or other subject of numericals. Okay. So first see that kgf 1 kg force is equal to 9.81 Newton or 10 Newton. 1 kilonewton is equal to, we all know that, Newton 10 raised to 3 Newton. Mega Newton is equal to 10 raised to 6 Newton. 1 giganewton is equal to 10 raised to 9 Newton. Okay. Then 1 megapascal is equal to 1 Newton per mm square. 1 gigapascal is equal to 10 raised to 3 Newton per mm square. But one conversions are taken, and from that we can also convert the unit. 1 megapascal is equal to 1 Newton per mm square. 1 Pascal is equal to Newton per meter square. Pascal is the unit of pressure, and also Newton per meter square is also unit of pressure. Okay. So 1 Pascal is equal to 1 Newton per meter square, and 1 megapascal is equal to 1 Newton per mm square. Okay, 1 Newton into meter is equal to 1 joule, of the obvious that 1 kilojoule is equal to 10 raised to 3 joule, 1 watt is equal to 1 joule per second, and 1 horsepower is equal to 746 watt. Okay, 1 degree is equal to pi by 180 radian. Okay, so from this relation we convert the unit to degree to radian, radian to degree, watt to HP, HP to watt, megapascal, pascal to Newton per meter square. Okay, so if we know this relation of conversion, then from that we can convert our unit to SI unit. Okay, now the other term is given is a scalar quantity and vector quantity. Scalar quantity, which quantities are defined without any kind of directions, only defined by the magnitude, direction is not needed, that type of entity is called the scalar quantity. Means the mass, to describe the mass only value is given, means 5 kg mass, 6 kg mass, the direction is not needed to describe that. Okay, sorry. Okay, and the vector quantity are defined by the magnitude plus as well as the direction, like a velocity. Velocity is defined by the magnitude, means the 20 meter per second in south direction, in west direction. Okay, the direction and magnitude both are defined. The quantity means the velocity, then this entity is called the vector entity, means the velocity is the vector quantity. Okay, the vector quantity example we see that the velocity, displacement, acceleration. Okay, it's all example of vector quantities. Okay, now let's take some conversions of unit. Okay, simple conversions are there. If 100 megapascal, 1000 megapascal are given, then what is the kilonewton per mm square? Okay, so here given that 1000 megapascal is equal to 1000 Newton per mm square. How do we know that? We already seen that 1 megapascal is equal to 1 Newton per mm square. Okay, so we know that 1000 megapascal is equal to 1000 Newton per mm square. Okay, now we have to convert the Newton per mm square to kilonewton per mm square. So we have to go Newton to kilonewton. So we have to divide the by 10 raised to 3. Okay, so a value is divided by 1000. So 1000 is cancelled, and the 1 kilonewton per mm square of 1000 megapascal. Okay, and the other is given is a 10 raised to 9 kilogram to gigagram, means 10 raised to 9 kilogram, then how much gigagram is there of 10 raised to 9 kilogram. So here the 10 raised to 9 kilogram is given. So 10 raised to 9 and 10 raised to 3 multiply, then we know that convert into the gram by multiplying a 10 raised to 3. So first convert into the gram. So 10 raised to 12 gram, 9 plus 3, 12 gram, 10 raised to 12 gram. So first we have to convert from kilogram to gram by multiplying a 10 raised to 3, and now we convert in gigagram. So we have to go gram to gigagram. So divide by, we know that 10 raised to 9. So giga is a 10 raised to 9, is divided by 10 raised to 9. Okay. So 12 minus 9 means remaining is a 3. So 10 raised to 3 gigagram of 10 raised to 9 kilogram. Okay. Similarly, how much 2000 micrometer to millimeter? Okay. So it's your homework. You have to convert 2000 micrometer to millimeter. Okay. So we discuss in our discussion lecture. Okay. So all of you convert this 2000 micrometer to mm. Okay. Okay. I hope that you all very well understand the basic terms which are helpful in this subject, mechanics of solid, and you also understand the which kind of science, what is the mechanics and what is the strength of material. Okay. So, and thank you for listening the video. Thank you.